Hello everyone and welcome back. In this session, what we're going to be doing is continuing on just a few more practice questions. The major point again is just slowly as we proceed, continuing to look at questions we've solved before, but brief or in some way, shape, or form, attempting to increase the difficulty so that we become familiar with the capabilities of these different programs. So the first thing we're going to do is look at the homework problem from last time. This is the shirt shop problem, and again, we have looked at this before. In this situation, we make t-shirts with logos and we sell them in retail stores. Shirt shop contracts with two different plants, one plant in Puerto Rico and one in the Bahamas. The shirts from the plant in Puerto Rico cost 46 cents, and 9% of them are defective and can't be sold. The shirts from the Bahamas cost 35 cents, but they have an 18% defective rate. ShirtStop needs 3,500 shirts. To retain its relationship with the two plants, it wants to order at least 1,000 shirts from each. It would also like to at least 88% of its shirts to be saleable. This is, again, a problem that we've looked at in the past. And the reason we're focusing on it here is because it is a slightly more complex problem than those we have been doing using the computer. But we're going to see today that it isn't anything that the computer can't handle. Instead, it's a program, or it's like the other ones, simply a matter of writing in to our computer programs the mathematical equations effectively. So, without further ado, let's begin. We see several things here. The objective function should be very clear. It's minimizing z at 46 cents x1, which is shirts from Puerto Rico, and 35 cents x2, which is shirts from the Bahamas. That part was very easy. But let's look at our next section. First, we see that 9% from Bahamas are defective, and 9% from Puerto Rico are defective, and 18% from the Bahamas are defective. So we can convert that to a fraction, or to a decimal, and it's 0.91x1 plus 0.82x2 must be greater than or equal to 3,080. And we see that from the last sentence. It says 88% must be saleable. So of the 3,500, we multiply by 88% and we get 3,080. So our first constraint becomes 0.91x1 plus 0.82x2 greater than or equal to 3,080. Our next constraint, we see that we have to order at least 3,500 shirts. So x1 plus x2, the total from both factories, must be greater than or equal to 3,500. And our final two constraints, to retain its relationship with the two plants, it wants to order at least 1,000 shirts from each. So x1, which is shirts from Puerto Rico, must be greater than or equal to 1,000. And x2, shirts from the Bahamas, must also be greater than or equal to 1,000. x2 must be greater than or equal to 1,000. So once we've formulated this problem effectively, just like this, then we can go into our two programs and begin to solve. Let's go into QM first. So we go to Format, our Module, Linear Programming. We open a new file, and this is the ShirtStop example. We have 4 constraints, as we just saw, and 2 variables. We are trying to minimize our costs. So we hit OK and we move on. Let's make these a little bit bigger for now. So our first one is Puerto Rico. Our second, Bahamas. We're trying to minimize if it's 0.46. Oh. 0.46. 0.35. One thing to be very careful with is we have to make sure that we are in a situation where we are not typing mistakes into the program, which will naturally ruin our analyses. So be very careful when you're entering the data into these programs. Our first constraint is maximum defective. Our second constraint is total shirts. Our third constraint is supply Puerto Rico. And our fourth constraint, supply Bahamas. We come over here. We know that with our maximum defective, we know it's 3,080. Oh, I did it again. So again, please be careful when entering the data. The next one is 3,500, 1,000, minimum from each factory, so 1,000 and 1,000. Each of these in this situation will be greater than or equal to. So then we come over here and we enter our relevant data. 0.91, 0.82. Down here we go to 1 and 1. Supply from Puerto Rico is 1 and 0. And finally 0 and 1. Once we've entered all of this relevant information, we are free to continue. Very simply, we hit the Solve button, and we see right here that we have a minimum of 3,500 shirts because we're going to order 1,000 from Puerto Rico, 2,646.34 from the Bahamas. So a total of 3,646 shirts. We also know that if we do this, our costs are going to be $1,386.22, and that is the absolute minimum we can expect if we hope to fulfill these conditions. Oh, and I see right now we're going to edit the data because a mistake was made here. This has to be 3,500. Nothing changes in that situation because the other constraints were powerful enough that they were the constraint that I actually changed does not have an effect on our final solutions. So this is our final solution in this situation. I'll save my file. And I'll close QM. Next up, we have Excel, shirt stop example, and we list our products here. In this situation, they're not products, so we'll change it. Not that it matters, but we'll change it for simplicity to factories. So I'll make all of my columns wider, just like I always do. Our first factory is Puerto Rico. Our second is the Bahamas. Here we enter our cost, and this is our objective function, 0.46, 0.35. Oh. Now we'll come down here and we'll do our resources where we're going to enter in our constraints. The first one is max defective, total shirts, supply Puerto Rico, supply Bahamas. We come over here and our actual usage, which we're going to compute with our formulas, and the total available. So we come over here, max defective, we know the number is 3,080. Total shirts is 3,500, 1,000 from each factory. Well, now we'll move on one more time. We know from before that they'll all be greater than or equal to, so we can do that and quite simply fill down using Excel's functions. We cannot type in our usage formulas yet because we don't have the relevant cells recorded, but we can enter this information here. So it's 0.91 per order from Puerto Rico, 0.82 per order from the Bahamas. Now we do that again one more time. Total shirts is 1 and 1. Supply from Puerto Rico greater than or equal to 1,000, and 1 greater than or equal to 1,000. So we've entered all of the relevant data in here. Our last step, as always, is to come down here and re-enter our factories. The first one is Puerto Rico. The second is the Bahamas. And then our ultimate goal is to min costs. Now, once we've done this, we're going to begin entering all of our relevant information, all formulas. So our first formula is the amount defective times the amount ordered plus the amount defective in the Bahamas times the amount ordered from the Bahamas. Here we have the amount plus or times Puerto Rico plus times Bahamas. Very simply here times Puerto Rico and here times the Bahamas. All of our relevant information was added here. The last one we have to do is our minimum cost. So equal to the cost per Puerto Rico times the amount ordered from Puerto Rico plus the amount in the Bahamas times the amount ordered from the Bahamas. And this completes the problem setup for Microsoft Excel. This should be getting very easy at this point because we've seen quite a few examples. So let's move on to the solver function. We click on data. Over to the right hand side we click on solver. Our minimize cost is B17. That's correct right now. We want to minimize. We're changing these variable cells B14 and B15. And we're adding our constraints. The first one, which is the amount that we get here, must be in this situation less than or equal to or greater than or equal to 3,080 right here. Over here we add that in. The amount here must be greater than or equal to this amount here. We add another one, greater than or equal to, and again, F9. And the last one, the amount here must be greater than or equal to F10. We hit OK. and all of our constraints are recorded. Change to simplex LP as always, and then we hit the solve button. And what we find is that a solver found a solution. All the constraints and optimality conditions are satisfied. And we see here, it is exactly as what we found previously. We have 3,080, so the first condition is satisfied. 3,646, so our second condition is satisfied. 1,000 from Puerto Rico, our third constraint is satisfied. 2,646 from the Bahamas, our fourth constraint is satisfied. If we order 1,000 shirts from Puerto Rico and 2,646 from the Bahamas, we are minimizing our costs at $1,386.22. That is our optimal solution. So this is the exact same formula or the exact same results we found from the previous section. And we see that it doesn't matter if we use Excel or if we use QM, we still get the same results. Let me save my file. And once that's completed, I can close Excel. And we come back here to our PPT. Now, we're going to do one more problem now before I leave you with the homework solution. So we'll go a little bit faster this time so I can leave you with a little bit more time to do the homework solution. Copperfield Mining Company, and this is again a problem we've solved before, so this should be relatively straightforward. We're going to skip this section and go right to the problem formulation because that should not in any way be problematic for you anymore. And we arrive at this. Minimize z equals 200x1 plus 160x2. Subject to 6x1 plus 2x2 is greater than or equal to 12, which is the amount required of high-grade ore. 2x1 plus 2x2 is greater than or equal to 8, the amount required of medium-grade ore. And 4x1 plus 12x2, which is greater than or equal to 24, the amount required of low-grade ore. This is what we are trying to do is minimize z, or costs, and 200x1 plus 160x2 is the costs associated with running different mines per hour to attain the ore that we are looking for. So once we've found this section, very simply, we can move into our computer programs. This time, we'll do Excel first. There's no reason why, just something to do for variety. So I'll open Excel. I click on blank workbook, and the first step is, this time I'll do it in the right order. We'll make our columns a little bit wider. We click here, and it's the copper mine example. So our choices are mine 1, and mine 2. Our costs associated with the two mines are 200 for mine 1 and 160 for mine 2. This is our objective function that we found right here. Now we'll come back in and we'll go over here and list our constraints. Minimum high-grade ore, minimum medium-grade ore, minimum low-grade ore. So we'll just make this a little bit bigger. And these are the 3 constraints that will be governing our decisions. We come over here, and we'll title it this time, Ore Mined. Now the titles, again, don't really matter. They're strictly for your comprehension or the comprehension of somebody looking at your spreadsheet. So we have or mind in this situation. And then minimal requirements, because we know how much we have to mine. So we can enter this information now. From our problem formulation, we know we require 12 tons of high grade ore, 8 tons of medium, and 24 tons of low grade ore. And these are minimum requirements, so it has to be greater than or equal to these three options. Now the actual ore mined we cannot determine yet because we don't know how much, but we do know how much we get from each mine. So high grade ore is 6 and 2. Medium grade ore is 2 and 2. Low grade ore is 2 and 12. 4 and 12. So now that we've got that information added, we can very simply move on down here, just as before, and we're going to list our choices again. But this time, instead of doing it there, we'll do it over here. Not that it matters in any way, and that's my point. That's what I'm trying to show you here. The cells don't matter. What matters is how we enter the relevant information into the solver. So just for demonstration purposes, we'll scatter this information a little bit. And we're trying to minimize our costs. Okay, so if we want to determine how much ore was mined, we have to take the amount from mine 1 times the amount from mine 1. Amount per mine 1 times the amount from mine 1, plus the amount per mine 2 times the amount from mine 2. And it's still 0. It doesn't matter where these cells are located as long as we add them appropriately. So here, and we're done. So again, normally our choices are over here, but it doesn't matter as long as we enter the information correctly. And in this situation, that would be F16 and F17. F16 and F17. We see is identical for all three. So we come over here to total costs, and we have to enter our total cost formula, which is the cost per mine 1 times the amount from mine 1 plus the cost from mine 2 times the total from mine 2. And we get total costs of 0 because we haven't mined anything yet. Once that information's taken care of, we come up here as we always do to the data solver. And the only difference now is we have to be a little more careful when entering the key information up here. So our set objective is located in this time in C19. We're trying to minimize by changing the cells F16 and F17. And we have to add our constraints as always, which is the minimum high grade ore. The ore mined has to be greater than or equal to the minimum required. We add that. The ore mined has to be greater than or equal to the minimum required. And the last one, the ore mined has to be greater than or equal to the ore required. We hit enter, and we are finished after we change to simplex LP. So in this situation, I have once again solved the problem. We have a scenario where very comfortably we can hit solve. Solver found a solution. All constraints and optimality conditions were satisfied. What we see here is that we are going to mine 1 hour of mine 1 and 3 hours of mine 2, which will give us a total cost of $680, but still satisfy our 3 minimum requirements, with only low-grade ore being overly mined. We can see we're mining a total of 40, which is much more than 24, but we need to do that to get to get high-grade and medium-grade ore to appropriate levels. So that's how we do it. We're going to save our file. As the copper mine example, and we can close this system. Next, we're going to pull up QM. We click on Module, Linear Programming, and we're going to enter a new, or start a new project. The copper mine example, we'll throw a title on there. Our number of constraints is 3, our variables is 2, and it's a minimization. Click OK. And we move on. We'll make these a little bit bigger for now, just to make it easier to read. Our first one is mine 1. Our second choice, mine 2. We're minimizing if it's $200. Oh. And $160. Our constraint is, we'll make our constraint one bigger too, because these are going to be quite large. Minimum high-grade ore. Minimum medium grade ore. Minimum low grade ore. Now we have all are set to greater than or equal to because it's set as a minimization problem. We know that we require 12 units or 12 tons of high-grade ore, 8 tons of medium-grade ore, 24 tons of low-grade ore. We come over here and very simply enter our relevant information. 6 and 2, 2 and 2, 4 and 12. So we have successfully entered all of the relevant data. All we have to do now is use our solve function, and it produces exactly the same information that we had from last time. We see that we're going to mine 1 for 1 hour. We're going to mine 2 for 3 hours. That will give us all of our requisite amounts, and it will cost us our minimized amount of $680. So we have successfully completed this problem. Let me save it 1 second. And we can close this. So we move on, and we've solved both problems successfully. The last thing you have to do today is solve the homework problem that I'm going to leave you with. So if you have any problems, I'm leaving you with a little more time now. We've gone a little bit faster. You have a little more time because it is slightly a more difficult problem. So good luck with that. If you have questions, as always, please contact me. And as always, I will address the class at the 40-minute mark. Good luck solving this problem. All right, everyone. Thank you for watching. As always, we'll continue next class with a review of this, and you do have to complete your answers before the end of the class time. Thank you again.